Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. We now delve into, for your trigonometry course, the double angle identities. These identities, which you can see on your screen right here, these identities end up being incredibly important as you move forward. They are memorizable, at least the ones for the sine and the cosine. Those typically are the ones students have to have in their brains at all times from this point forward. There's no exception to that. In fact, most of the trigonometric identities, the sum and difference identities, that was the video or series of videos that you likely just watched in my video series on YouTube. And then this, the double angle identities that you're seeing here. And then in the future, a few videos away from this video, the half angle identities. Again, for the sine and the cosine. There is an identity for the double angles for the tangent. I just don't require that my students memorize that identity because you can always derive it just from knowing the double angle identities for the sine and the cosine, because the tangent is equal to sine over cosine. Anyhow, so let's go ahead and in this video dedicate our time to the theorem and the proof of the double angle identities. It's very fast. So first of all, the identities themselves. The sine of twice an angle is 2 times the sine of the angle times the cosine of the angle. And I'm using alpha as the angle here. If you didn't know that, that's the Greek letter alpha, lowercase alpha actually. Cosine of a double angle has 3 forms, and which one you use just depends upon the situation. So let's say that you are working on a problem in this course, or your pre-calculus course, or maybe your calculus course, and you happen to know the sine of alpha, and yet somewhere within your problem you have to work with the cosine of the double angle, or cosine of twice alpha. Well then, if I already have the sine of alpha, I will use this version right here, because then I can trade it out for that cosine of the double angle. So that's just to let you know that the triple form here for the cosine of double angle is actually very, very important to remember, and to derive it's really easy. You don't actually have to remember all 3 forms. You can just remember the first form and derive the other 2 very quickly. And that's where you want to be, by the way. You want to be able to derive these really quickly without having to memorize, let's say, these alternate forms, these last 2 forms for the cosine right there. You want to be able to derive those types of formulas as quickly as possible. So when you watch these videos and you watch me prove something and you go, man, why am I even bothering with the proof part? Because all I need to do is memorize these things. The reality is that the proof part is important because you may forget the actual identity, but knowing how to prove things is incredibly powerful. It allows you to derive stuff, simple stuff like this, very quickly. And then finally, we see that tangent only has 1 representation, and that's perfectly fine because, again, I would never have my students memorize that. Now, let's go ahead and prove the sine and the cosine double angle formulas. It's very fast. So one thing that has to be assumed here is that you know the sum formula for the sine. So what do I mean by that? The videos I just finished and are on YouTube, and it's assumed that you've just watched them, allow you to take something like the sine of twice alpha, which is alpha plus alpha, and break that into the sum and difference formula for the sine. So the sum formula for the sine is sine of the first angle times cosine of the second angle. So that's the second angle and that's the first angle, but they're the same angle in this case. And then remember, sine keeps its sign. So if it's a plus for the sine in between the two angles, it's a plus in the sum and difference formula. And then plus sine of the second angle, which is again the alpha, times the cosine of the first angle, which is again just the alpha. And if you count them up, you have two of those sine cosine of alphas. So that is just going to equal 2 sine of alpha cosine of alpha. And that is the proof. Really fast, right? Especially when you think about all the other proofs that we've done, this is probably one of the fastest proofs. And luckily, the cosine of the double angle is proven just as quickly. So let's go ahead and do that one. The cosine of the double angle, that's what I call it, of the double angle, is the same thing as cosine of the first angle, which is alpha plus the alpha again, because there's two alphas. And of course, we know that the cosine of an angle plus an angle is cosine of the first angle times cosine of the second angle. And then remember, cosine does not keep its sign. So if that's a plus, it will be a minus here. And then sine of alpha, or sine of the first angle, times sine of the second angle. And you can see that's cosine alpha times cosine alpha, which is cosine squared of alpha. I'll write that in here, cosine squared of alpha. And then minus sine times sine is sine squared of alpha. And there we have it. We have proven the second, or at least the first part of the second identity. Now let's go ahead and prove the alternate forms for the cosine of the double angle. And again, their proofs are actually derived very quickly from the base form. So we have just proven that the cosine of the double angle, this guy right here, is equal to the cosine squared minus the sine squared. Now we do not have an identity to change that cosine squared of alpha minus sine squared of alpha to anything right now. Because remember, it's cosine squared of alpha plus sine squared of alpha that turns into 1, not minus. So that's just something that throws people off. But speaking of that identity, I'm going to go ahead and write it off to the side. We know that cosine squared of alpha plus a sine squared of alpha, well, that's 1, which lets us know that we could technically solve for the cosine squared of alpha by subtracting sine squared of alpha from both sides. So everywhere I see in this picture right here a cosine squared of alpha, I could trade it out for a 1 minus sine squared of alpha. I'll use blue ink actually to do that. So another form of this would be 1 minus sine squared of alpha. And then we still have that minus sine squared of alpha off back. But that means you're losing 2 of those sine squared of alphas. And if you look at that, that is actually the third form. Now, alternatively, we could have solved the Pythagorean identity for the sine squared. So I could have said, well, let's isolate just the sine squared and we'll subtract cosine squared. That was supposed to be a C, sorry about that. But we could have subtracted that cosine squared of alpha from both sides. If we do that, we then can go back to, again, our original formula for the cosine of the double angle there. And we could have said, okay, instead of a cosine squared minus a sine squared, we'll trade that sine squared out for a 1 minus cosine squared. So doing that, and I'll write it above, we would have had a cosine squared of alpha minus, and you have to use parentheses here. You know from algebra that when you subtract, and if you're subtracting a statement and you trade that statement out for a different statement, you should put parentheses around, because if you don't, you're likely to get things terribly wrong. So we're subtracting this statement, 1 minus cosine squared, because 1 minus cosine squared is the same thing as sine squared. And of course, that is equal to, I'm going to move it up here a little bit, cosine squared of alpha minus 1 plus cosine squared of alpha, because the negative distributes. So you have 2 of those cosine squareds of alpha minus 1. And that is actually the second alternate form. So deriving those is very quick. You just use the Pythagorean identity to do that. And like I said, I'm not going to bother deriving the tangent of the double angle. Most textbooks would have that along with actually the sine, the cosine of the double angles. But I think it's good enough that we went through at least this part of it. Now what we're going to go ahead and do is in the next video, use these identities to go ahead and do a bunch of different styles of problems.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.